So we'll see about sorting an array of data using ADT. We'll have a series of 8 data. So first of all, if we're given a random array, say we are provided with. So our array is 6, 4, 8, 7. Now we need to sort it in ascending order. So to sort it in ascending order, we first use bubble sort technique where adjacent element are compared. In this case 6 is compared with 4. So 4 is less than 6, so 4 and so 4 is less than 6, and so 4 and they are swapped, and the first element becomes 4 and second 6, third 8 and fourth 7. Now 6 and 8 are compared. 6 is less than 8 and so it is not swapped. And now 8 and 7 will be compared and 7 is less than 8, so they are swapped and it continues. So this is about one pass, and this pass number of passes is equal to the total number of elements in the array minus 1. So there are 4 elements, so there will be 3 passes, and in each of the passes there will be this many number of comparisons. And the number of comparisons will go on reducing as the number of passes increases. That is, in the first pass you have 1, 2 and 3 comparisons, but in the second pass you have 1, 2 and 2 comparisons, and in the third pass you have only 1 comparison. So because in bubbles of the largest array element of the array settles the n position in the array. So we'll see how to do this in 8085 microprocessor. So first of all, load the address into the HM register pair, and then clear the D register and get the count value of the array into the C register from 4150 location. Then increment H and get the first data value from 4151 to accumulator. Now increment H and get the next value and compare accumulator value and memory value. Now if there is no carry, then accumulator value is greater than memory location value. That is, the first data is greater than the second data, and since we are producing an ascending order array, we need to swap these two elements in bubble sort technique. So the first data and the second data are swapped using this code, and if swapping happens, you initialize the D register with 0, 1. You do DCS H to move to the previous memory location where the first data is and put it into the second data position, and similarly you do INX H to come back to the current location. Now D register is initialized with 0, 1 if and only if swapping happens. So next thing you'll be doing is decrement the count value. So if you decrement the count value here and you move it is not 0 in this case, where 4 minus 1 is 3, so it's not 0, so it again moves to part 1. Part 1 will move a comma n. Again the first data value is taken, the next two data values are taken, third that is the second and third, and they are compared and they sorted accordingly. Similarly the third and fourth again DCLC, and then the third and fourth data are compared, and then once this condition becomes invalid, you move to this condition. If swapping happens, D register is 0, 1, so 0, 1 is moved to accumulator. Now RRC rotates right the accumulator value, so 0, 0, 1, 0, 1, so this one will be shifted to carry, and so carry flag is set now. So if carry flag is set, move to the start location again, then get the data value from the beginning and move to the next pass. So D register is for the pass value and C register is for the comparison value. That is, the array is passed as many times as the swapping takes place. Once there is no swapping that happens in the array, that means the array is already in ascending order and you need not go to further passes. So that is what this D register indicates. And you terminate the program and check your output in the memory location. So in this case, this is 4150. So we'll have your count value, and so we'll have count value is 3. This 3 we have 4 data, and so it is 1, 2, 3 and 0, 1, 4 have a step-by-step execution of sorting in ascending order, where our count is 3 and the number of data is 4. So as you can see, this is the first pass. Now this is the first pass second element comparison. Now the first pass third element comparison. And now this condition comes true and we move on to the second pass. So in the second pass again the element comparisons again, and we move on to the third pass, and the third pass element comparisons are being done, and finally so there are 4 element comparisons that have been going on, and finally it's the last pass where you check if there's no more element to be swapped, because in the previous pass we had elements swapped, and in this case we have no elements to be swapped, and so D register is not initialized with 0 1, and so RS doesn't happen and the program is terminated, and you have the sorted array in your on this location. As you can see, we have given 4321, which is a descending order array. This is the worst case for the program. So it has been sorted into the descending order. You can see 0 1 2 3 4, where we had given before is 0 4 0 3 0 2 and 0 1. That was the descending order array. Now it's being sorted into an ascending order. So you should remember one thing, that when I give a count 3, number of data will be 3 plus 1, that is 4. 1 2 3 and 4. So that is about sorting in ascending order. If you need to sort the same data into descending order, then the only thing you need to change here is you need to give jump on no carry, because jump on no carry means if there is a carry, only then these instructions will be set. That is, if the first data is less than the second data, then those two data will be swapped because it's a descending order array. So if we execute the same thing again, this is the first pass, first element comparison, that is 1 and 2 are compared, and this is the first pass second element comparison, that is 1 and 3, that is 1 and 2 are swapped, and now second position we have 1, so 1 and 3 will be compared, and 3 will be put in that position, and this is the third element comparison, and yeah. So this is the next pass, and so in every pass there is about same number of element comparisons going on here. This is quite different from bubble sort technique, where in bubble sort technique the number of comparisons keeps reducing by 1 in each pass. In case of a programming method where you are using C++ or any other equivalent language, but here we are comparing the same number of times in each pass, and we are having n passes. That is, if an array has n elements, we are having n passes, where the nth pass is used to check whether no swapping happens, if any swapping happens. So this is a variation of bubble sort technique. Yeah, so execution has completed successfully. So we move on and check. Our count value was 3. Our data initially given was 1, 2, 3, 4, that is ascending order. In this case, it's the worst case for this particular program. So it is 4, 3, 2, 1 is our output. So we have got a correct output. So that is about sorting in descending order. So we have learned about sorting in ascending and descending order.